difference formulas. I probably introduced them to you in a matter of a split second because we kind of didn't need it as much last year. This year we're going to utilize it a bit. So I'm going to talk about that a little bit. The good news is you don't have to memorize it. It is on your bright colored sheet of paper. Oh, everybody got pink. That's nice. How'd that happen? Okay, so then if you look about more than 3/4 of the way down, it says sine A plus minus B.
Yeah.
It says cosine A plus minus B. And it says tan A plus minus B.
Yeah.
Okay? Those are the ones that we're going to utilize today. All right? So here's how this works. You didn't get pink.
I'm the one on
You
the
are the one
first
on
left
all.
out.
That's okay. We still love you.
Yeah, I think he took it because I got me then.
What?
Because I'm getting out. He's not. He's going to stay with me forever. Okay, so if I said, what is the sine of 30 degrees? If I said, what is the sine of 30 degrees?
1/2.
You guys would say 1/2. And how would you get 1/2?
The unit circle.
Yesterday we looked at our unit circle. We said 30 degrees. Where is sine located? It's at y 1/2. Okay? So really comfortable, right? What if I said, what is the sine of 45 degrees? Once again, we would go, okay, that's not a problem. I recognize 45 degrees. It is on the unit circle. Sine is a y value. It is square root of 2 over 2. Okay, are we comfortable?
Yeah.
So far, so good. What if I said, what is the sine of 75 degrees? Then you would say, hold your horses, Miss Kay, let me get my calculator out. I need to figure out what it is. But the problem is, and we know this is not going to be a problem on an AICE exam because you get to use a calculator at all times. But what if it said find the exact value? Well, that makes a little bit of a difference because when you plug it in your calculator, you're not going to get that exact value that you're looking for. So the way that we work this is something called the sum and difference formula. You look at the number 75 and you say, can I make a combination of known unit circle values and adding 2 or subtracting 2 that potentially could give me this number 75?
Yes.
And yes, we can. What are they? 30 and 45, right? Does that make sense? So what we're going to do is we're going to rewrite this as the sine of 30 plus 45. The first question you asked me is, does it matter what order I put them in? No, it doesn't. As long as they add up to the 75, yes.
So you could do the sine of 60 plus 15, and that would work
But
too.
is 15 on the unit circle?
No. So you want to find numbers that are on the unit
You
circle.
would like that.
Yeah.
That's the way to make it. Yes, right.
In the case of subtraction, it would matter though.
It would matter. Everybody in? All right. Nice.
Oh, I didn't sign it.
It went right by you?
It did.
Okay. So is everybody cool so far? Okay, so now you're going to use your handy dandy bright colored formula sheet. You're going to scan your eyes down to where it says the word sine, y sine, because that's the one I'm utilizing. You're going to look for the one that says sine A plus B. Why A plus B? Because we use 30 plus 45. Okay, so what is the sine of A plus B? Well, the way this works is this actually is two different formulas. The first is A plus B. The second is A minus B. Okay? If you scan your eyes across, what you see is sine A, cosine A, and then they have a plus and a minus on the bottom. You see that visually? So the top goes with the top. The bottom goes with the bottom. So what I mean by that is sine of A plus B is going to be sine of A, cosine B, plus cosine A, sine B. Did that make sense what I just said? So if I was looking at the subtraction, it would be sine A minus B, and that would be sine A, cosine B, minus cosine A, sine B.
So if it's minus, you just make it minus.
Yeah, in that case. Look at cosine. Of course they have to flip it up for us, right? Look at cosine. Cosine of A plus B, plus minus B. Scan your eyes across. What does the plus match up with?
Minus.
The minus. And what does the minus match up with?
Plus.
The plus.
So
Okay?
that's the opposite.
Correct. And the words are a little different. Notice sine, sine, and then cosine, cosine. Do you see what I'm saying?
Yeah.
So, again, the beauty of this particular part of your lesson is you don't have to memorize this. It's given to you. And it will be given to you.
So it's in the sine one. It's just it doesn't matter what you add or subtract. It's just both variations, like sine of A, cosine of B, and then sine of B, cosine of A.
Correct.
It doesn't like.
That's why order doesn't matter in that
Yeah.
case.
And then
Yeah.
the next one, I'm kind of confused on what you were saying. Like, are you saying that if it's plus U minus?
For
on the other
cosine. So
side?
the
Yeah.
thing, the sign,
Okay.
the symbol,
Yeah.
the sign on top corresponds to the sign on top. Did that make sense?
Yeah, because,
Okay.
so like, if it was cosine A plus B, it would be cosine A, cosine B minus sine A, sine B.
Exactly.
Thank you.
Okay, so now let's finalize this. We have, if I'm looking at the formula, it says sine of A in this case is 30, right? And then it says cosine of B plus, and then it's going to be cosine of A, sine of B. Everybody good?
Yeah.
Okay, now, this brings us back to something we should be familiar with. What do I mean by that? Well, I know what sine of 30 is. I know that because it's on the unit circle and sine of my y value is 1/2. So this is going to be 1/2. Is everybody good? What is the cosine at 45?
Square root 2 over 2.
Square-
Square
yeah.
root 2 over 2. And truly, these two things are multiplied together. We're going to do it slowly.
Square root 2 over 2.
Uh-huh.
And then what is the cosine of 30?
Square root of 3 over 2.
Square root of 3 over 2, right? And sine of
Square root of 2 over 2.
square root of 2 over 2. So far, so good?
And now it's multiplying.
Multiply. So 1 times the square root of 2 is the square root of 2. 2 times 2 is 4.
Mm-hmm.
Plus the square root of 2 times the square root of 3 is the square root of 6 over 4. And there's your answer. Yes?
Wait, no, you can't break down square root of 6 anymore, right?
No. It doesn't have that perfect square in there. Yes?
Do you add them together?
No.
You can't.
Well, I mean, you can
You
add,
could have a
like,
common
you
denominator.
can just put the
You could do
denominator
square root of
together.
2 plus square root of 6 over 4 if you
Yeah.
wanted to make it a little
Okay.
cleaner. Yeah.
I like it.
Typically, this is where you leave it. Now, the sine one is pretty straightforward. The cosine one is pretty straightforward. The tangent one, again, is really straightforward, but it confuses people.
It looks confusing.
It looks confusing, so let's
The
go
word
over
tangent
what
is
it is.
confusing.
Yeah, it scares everyone,
As soon as I
right?
hear it, I'm just like, oh.
It scares everyone. Okay, so let's say I want to do the tangent of 15 degrees.
Mm-hmm.
15 degrees, not on unit circle. Right?
You can do 45 minus 30.
Absolutely could. And any other variations?
Let's make it difficult. 330 minus 315.
You could do that as well. You could have fun with this.
I don't know if I'd want to work with those.
I try to keep it in the first quadrant, just because,
negative
you
Well,
know.
positive.
if you can keep it simpler, it would be ideal that you do that.
It would be nicer, but you don't have to. I mean,
45 minus 3.
Does everybody-
Why does it only go up in an interval of 30 right away from the x-axis?
honestly, I don't know. I know that it has to do with those special right triangles that you learned back in geometry, the 30, the 60, the 45, that's it.
Oh, okay.
So, it all correlates to that.
The
The
axis
ordered
is
pairs
just need
wouldn't
more.
be as neat. I
They're not
guess.
as pretty.
So
right?
basically put the neat ordered pairs.
And back in the dark ages, I didn't learn the unit circle. I never ever was taught. I learned how to recognize the sine wave and the cosine wave. And we had charts of numbers. You had a whole page of numbers.
Sounds like the Z
Of course,
score.
we didn't have
Yeah,
calculators.
it's
Like the Z-score chart.
So somewhat, yeah.
Whatever.
So my AP calculus exam, no calculator, is let's take our book of charts out. It was.
At least you got the book of charts.
Yeah, we got a book of charts. Okay, so is everybody cool with 45 minus 30?
Yes.
Yeah, like something in Skyrim.
Yeah. Okay.
Charts.
The book of charts. Now, let's look at tan. So tan, and what are we going to utilize? It's going to be subtraction, right? So minus. So it's going to be tan of A minus B, which is going to be tan of A, which is 45 degrees in this case, plus tan of B, which is 30 degrees. Am I wrong?
I thought you were doing mine.
Minus.
She just gave up and got another even.
She even looked down at it. She's like, nope.
It's done. And then let's go to the next one. 1 minus. I got excited. I got
This
to
is,
get too early.
this is plus.
Listen.
It's minus or
You
plus,
people just
right?
It is second period.
I love you too.
I'm confused on why you did plus there.
Okay, there. I am too, apparently.
Oh, wait, no, I got it. Never mind. I saw the sign.
Okay, good. I saw the sign. Yes, sorry.
So how do you know when to do positive or negative? I'm just.
Well, okay, so that obviously I'm doing a phenomenal job today.
Uh-huh.
So here's how this is. We have a subtraction in between, right? So here's the dilemma. You have to look at, initially, where does the subtraction lie? It lies at the bottom. So it'd be tan A minus B. So every symbol you're going to use, the sign you're going to use, is at the bottom. So if you look at the thing, which is, I didn't do a very good job, it's tan A minus, because that's at the bottom, tan B. And then it's 1 plus, because that's at the bottom, tan A, tan B.
So like, let's say if we were doing tangent of 45 plus 30, it would be in the top, tangent of 45 plus tangent of 30, and then the minus is going to be in the bottom.
Right.
So the bottom is always the opposite of what you're working
Correct.
with. Yeah.
Yeah, I'm glad you did that, because evidently I was rocking and rolling the wrong place. So is everybody cool with that? So now, what does it mean? What is tan of 45? Tan. Do you remember how to get tan?
Sine over cosine.
Sine over cosine. What is sine again? Y. I'm the only funny guy in the house here. So we have tan of 45 is sine over cosine, which is y over x, right? So it's going to be square root of 2 over 2 divided by square root of 2 over 2, which is 1, right? Yes.
And you have your special rule with when you divide fractions that have the same denominator, you ignore denominator.
I like that. Yeah. So let's redo that. Square root of 2 over 2, square root of 2 over 2, because they have the same denominator, ignore it. And it's just square root of 2 divided by square root of 2, which is just 1. Well, in this case, no, you shouldn't ignore, but. Okay, so 1. Are we good? That's tan of 45. And then minus, what is a tan of 30?
3 over 3.
1 over.
Just give me the originals, and we'll work it just for the
So
fun.
it's 1/2 divided by square root of 3 over 2.
Okay, and then my special secret is where you take this and you get rid of it, right? And you're left with, and typically we like to rationalize the denominator, okay? Reminding ourselves how to rationalize.
Multiply by the.
Multiply the top and bottom by the radical of 1.
Good. So this over this.
I was gonna say the radical equivalent of 1, but what else?
Well, and then we have 1 plus, and what's tan of 45 once again? 1. And then the tan of 30.
Is that just something you know? I feel like I should know that.
The tan?
Like the tan of 45.
Well, because the x and the y's are the same. And because when you find tan, it's the x, the y divided by x.
Okay.
So because they're the same, it comes out 1.
Alright. But it's just something that you know because you've done it a million times?
No, it's just because, yeah, well, I guess I reasoned through it.
Okay.
Yes, I've done it a million times, but yeah. So now what you're left with is 1 minus the square root of 3 over 3, and then 1 plus the square root of 3 of 3, and this is actually sufficient for your answer. You don't have to get a common denominator and all that.
What's the what is the thing where it's what's it called? That has a name where it's like something.
It's a complex fraction,
No, but I don't.
No, like 1 is minus on the top, but it's the exact same thing. added
like a
on the top.
conjugate. They're conjugates of each other. But
That's
that,
exactly.
But that's without. But that would have to have like x.
That's not relevant here, I
Not
feel,
so much.
but it's just
it's kind of cool.
Oh wait, I thought a conjugate had to have a variable.
No,
No. Okay. Cool.
as long as there's opposite symbols in between two same numbers. Yes.
How did you get square root of 3 over 3?
Okay, so, are you with me when our answer came out to be this? Were you good with that?
Yeah.
Okay, so I don't like the square root in the bottom, which is, it's okay. You can leave it like that if you wanted to. But to get rid of it, we do something called rationalize it. And to rationalize, we're going to do this to it. Which really, we're not altering it at all. We're multiplying it by 1. So when I multiply it through, I get the square root of 3 over 3. Is that cool?
Yeah.
All right. All right, are we comfortable with the sum and difference formula? The beauty of it is you do not have to memorize it. You just have to utilize it.
You just leave the answer like that.
Yeah, that's good. Done.
How many marks would the whole question of this be on?
This would not be a question. This would be like the
It's
last
part
step
one.
of a question.
Part of a question?
It's
Okay.
like a point, maybe.
It's like the cleaning up of. So it's a tool that you might use, you may never use, so I just wanted to introduce it just in case. Yes?
So what types of problems would be associated with this concept?
I would envision it being a multiple step problem where you would actually do some work first and then you would end up with tan of 105. And then you would have to work through that process of cleaning it up a little bit.
And we'll do some of those.
Well, yes, I'll find some. There's far and few between. But I just want you to be familiar with it. Yes?
So what if there's like a number that you can't get by like adding extra?
Then you go to the trusty old calculator, which, remember, on this test, you're allowed to use your calculator. So, I mean, this is kind of like, I'm gonna show you how to do this. You may never see it because you use a calculator.
So what exactly did we just find?
Well, we actually found the exact value of these things,
Tangent of 15.
Oh, okay.
of things that are not on the unit circle.
Like they don't have a pi, like exact value.
Yeah, they don't have a decimal answer, they're not approximates,
That's
yeah.
the ordered
So if
pair.
we put it into our calculator, we would get an approximate.
You know, I don't believe any of your calculators is gonna come up square root of 2 over 4 plus square root of 6 over 4. I don't think. I mean,
I have
No, mine
friends.
definitely won't.
I might be surprised, but I don't know. I think you'd come up with a decimal answer of it.
Yeah.
Yeah.
So since that's the tangent of that, that means
The
the
cotangent.
sine is 1 minus square root of 3 over 3, and the cosine is 1 plus square root of 3 over 3. So that would be the ordered pair if it were on the unit circle.
Which is very smart to remember. Who can remember it?
So
That's really cool.
Yeah. Well, because tangent is sine over cosine, so
Right.
yeah.
So
I wonder if that's how it all pans out. I bet. Okay, are we comfortable?
So if you need both, just do the tangent one, and you've got both of them without having to do sine and cosine
True.
formula.
They would give you like extra marks. They'd be like, this kid knows.
This
This
is
kid knows what he's doing.
This kid's just.
With the tangents.
Okay, so how are we feeling about that? Now,
You guys want to come grade A's math test for us?
well, that'd be nice.
Would you do that?
Grade 'em.
I mean, DJs in college out there were just like, you want to come to Britain and grade math tests?
That'd be fun.
Could
Yeah.
the sites.
Wow.
You gonna be all dapper every day and like drink tea?
Oh, I can't go
and
there.
Be all dapper.
This is as dressed as I get. No, I can't go.
She'd come back with a British accent.
Oh, well.
Hello, pupils.
Can you teach the rest of the class with a British accent?
I don't even think I could.
Can you try?
I could do it. Can I try?
She's being recorded. Don't make her do that.
Yeah, don't make me do that. It's like, who's this crazy lady over there? Okay, so the next
Use all
thing.
of the words. Of course. Can you do me a favor?
Theatre. In the theatre.
In the theatre.
I hope they don't watch this video.
I hope not either. They're gonna say my class.
In the coffee shop.
Now, the next thing we're gonna do is we're going to just review for a moment the 6 trig functions, okay? So,
That's 5 tricks too many.
because 5 is too many.
No, 5 tricks.
The 6 trigonometric functions are not really given to you on here.
Great.
Right.
So, let's talk about them. The first one is sine. The next one is cosine.
Oh, these are the 6 tricks.
Yeah. The next one is tangent.
I'd be
All right,
worried.
and here it goes.
And then
Cosecant, or
Good job.
cosine, or
Cosecant.
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 Secant.
I always tell you the one that doesn't have the same letter goes with that one, right?
So that makes sense.
Because that makes sense. And then secant,
Cotan.
and
Cotan.
then cotan.
tangerine.
Now, as far as we've been talking a little bit in the last day or two, talking about what are the letters that represent on the unit circle. We know this is y. We know this is x. We know this is y over x. Yeah? We know over here that this is going to be 1 over y, 1 over x, x over y. Okay? So keep that in mind. That's not what we're really utilizing today. What we are utilizing today are the actual trig identities. Okay? So if I'm looking at this, I know that the sine, cosine, and tangent, cosecant, secant, and cotangent. We naturally walked into one of the identities a second ago when we were working with the problem. The actual one we were working with was tangent, which by definition, sine divided by cosine is tangent. And vice versa. Cosine divided by sine is cotangent. Okay, everybody good with that? Yeah. Okay, so those are the 6 trigonometric identities. This is called the, I don't know the word, reciprocal identity, I believe is what they refer to it as. Having said that, there are 3 other identities that we need to be familiar with for this particular lesson. Okay, and these are called the Pythagorean identities.
Oh.
Now, here's the good stuff.
I think I know those.
The Pythagorean identity, if you look at your bright colored sheet of paper, is
The sine squared plus cosine squared equals 1.
right,
And then 1 plus tangent squared equals secant squared.
right.
Freakins.
And then cotangent squared plus 1 equals cosecant squared.
Where are you finding?
And you can rewrite them.
Above the sum difference ones.
Right.
3 lines.
Gotcha.
Yeah.
So we have sine squared plus cosine squared equals 1. Okay? Then the other one is going to be what?
1 plus tan squared
1 plus tan squared equals
secant squared.
secant squared. Beautiful.
And then cotangent squared equals 1, or plus 1 equals cosecant squared.
Now, forgot x's everywhere. Of course I did.
That's fine.
You
It's
guys
a
get it.
theta.
Who cares?
They're thetas. And then
Yeah, thetas, x's, whatever. Now, here's what they give you. So, yay, we don't have to memorize it. Dilemma. I talked about it last year a lot. You really have to kind of be able to manipulate and visualize. So if I'm looking at this, I see sine squared plus cosine squared is 1. And I do see a lot of happy people when they recognize that in a problem. They're like, oh, it's 1. I get that, you know. But what happens if I see something like this? 1 minus cosine squared.
Mm-hmm.
So people go, huh? What happens is if I subtract that over, I have to be able to recognize that 1 minus cosine squared is sine squared. Or vice versa. 1 minus sine squared is cosine squared. You're going to see that a lot. They don't typically give it to you in this format, too easy, but they give it to you in this format you need to recognize. Not given on your bright colored sheet of paper. And that is 100% true about this one and this one as well. So how can you manipulate these? Well, I could give you secant squared minus tan squared, right? That's 1. What else could I do?
Secant squared minus 1 equals tan squared.
Good. Secant squared minus 1 is tan squared. Gotta recognize it. Yeah.
So, when there's like, if you took everything on the one side, does it equal 0? Like, could you use that in a problem?
Yeah, sine squared plus cosine squared
Plus
minus
minus
1
is
equals 0.
And you could use that.
I wouldn't, because you zero something out.
Yeah, I mean, I'm just saying, like, in the case where, like, there's something you don't need, like, the problem, you know the answer is in, like, secants and cosines, and there's
Right.
like a tangent or something, and you see, you know, tangent plus secant or minus secant.
I probably wouldn't. Because the rule of the world, the rule of the land here is that you manipulate one side, not both.
Mhm.
So you're going to play with one side, but not the second. So you want to keep one side. Okay, so what's the last two here? Do you guys agree that cotangent squared is cosecant squared minus 1?
Mm-hmm.
And then 1 is equal to
Cosecant squared minus cosine squared.
cotan?
Or cotant, yeah.
Yeah. Okay, so why do I do this every year? Well, it's so important because you will, 100% will find this on a test. Yes?
What are the identities called?
These are called Pythagorean identities.
Like a squared plus b squared equals c squared.
Yeah. Pretty cool, right?
You spell that.
Pythagorean, that's a good question. P-Y-T-H-A-G.
O-R-E-N. E-N, yeah. E-N, yeah, it's pronounced the way it's spelled.
There.
Is it not A-E-G?
Pythagorean. I don't know. I'm very much a phonetic speller. Whether it's right
I
or
think
wrong,
that-
it sounds like it.
That word is very, yeah.
I think that's right. Yeah.
Until you hit the diphthong, and then it'll be bad.
Diphthongs are fine.
Oi,
Wait, which one?
oina.
Okay,
Nobody's
so,
saying Latin.
are we comfortable so far? So what I'm going to do now is pass this worksheet out, and we're going to kind of talk about some of the problems and how we attack them. Okay. Okay. As promised, we're going to do the verification and verify and simplify. Verify and simplify, we utilize Pythagorean identities. We use the regular quotient. Did I say that right last time? I call it reciprocal. Quotient, sine over cosine. Those are quotient identities. And we use just the plain out identities, like sine is equal to 1 over cosecant, etc. Okay? So those are the identities that we're going to utilize, half of which are on your bright colored sheet of paper, half of which are not in manipulation form. Okay? So keep that in mind. So what you have to do, these are actually, because there's an equal sign in between, these are not considered simplified. These are verified. If you ask me, these are easier because there's an end result. If I'm asking you to simplify something and don't tell you where you need to get to, some people get a little kind of like, oh, I don't know where to end. So the way you work these, if we can recall, there's some like old lady tricks. So the old lady tricks is you look at your stuff, you look at your picture, whatever you're doing, and you pick the hardest side. Okay, so step one, choose the most difficult looking part. It's easier to take multiple fractions and condense them down to one rather than a single fraction and make it bigger. Okay? The second step that you're going to use is that you're going to convert things to sine and cosine, because sine and cosine is a lot easier to work with. That's kind of like 90% of the time we do that. Sometimes we can just recognize and use. Okay? And then it's just kind of like basic algebra that you have to kind of work through to kind of get where you need to get. So we're going to start with a simplistic one and we'll work our way into a more difficult one. We're going to work on number 3 together for a moment. Okay? So we have secant of theta, sine of theta, over tan of theta plus cotan of theta is equal to sine squared of theta. Okay, so my first step was, let's pick the uglier side.
Mm-hmm.
Is it quite obvious?
Yeah.
Yeah, it's easier to make a large fraction condense into something smaller than something small to expand. Okay, so if I'm looking at this, I have secant theta, sine theta over tan plus cotan. That's obviously the more difficult. I'm going to manipulate that side only and not touch the sine squared at all. So then the next thing I'm going to do, what was my next step?
Get them all to what you want.
Get them all to what you want.
Sine.
I say turn into sines and cosines. Easier to work with. So if I look at secant, what is secant equivalent to?
1 over cosine.
1 over cosine. So secant is 1 over cosine, and sine is sine, over 1 basically. And tan is
Sine over cosine.
sine over cosine by the quotient identity. I called it the wrong thing earlier, of course. And what's cotan?
1 over tan or cosine over sine.
Cosine over sine was where I would go.
I was like, oh no, did I get it wrong?
No. It is indeed 1 over tan, but that's not moving into the sines and cosines, right? Now
Wait,
what?
It is also 1 over tangent? Oh, interesting.
Because they're reciprocals of each other. That's where that word came
You
in.
can combine the top.
Yeah, you can multiply the top through, so that would be a natural next step, right? So the natural next step would be sine divided by cosine. Eventually, I'm going to get this. Sine divided by cosine. Okay, everybody cool with that? That's natural? Yes.
For the bottom one, you need to have a common denominator.
Yes. And remember my old lady trick?
There was some multiplying.
It's
It was like a cross.
It was like a cross. And, okay, let's do an easy one for a minute. Side panel here. If I have 1/2 plus 3/6, right? Obviously that's an easy one. But having said that, how do I do it in my head pretty quickly? Okay, I do. I take I start from the bottom, this guy here. I multiply this times this. I get 6. That's the same symbol. I multiply this times this. I get 6. Over this times this.
12.
Mhm.
12 over 12 is 12.
There's your answer.
I
So-
remember some of
You
this.
did the math.
And why do I start with this one down here?
Because you want that to be your first, you want the top, the numerator of the first term to be the first one. Like whatever you're multiplying it by.
Yeah, because if my problem was this, right? I need subtraction and I need this guy to be my first number. So how would I do that? I would do this times this, 21, minus this times this, 4, over this times this, and what do I get?
17, 28.
There's my answer.
Ms. K?
Yes.
So my way of doing it is I look and, like for the 7, multiply that by the other denominator.
Sure.
And multiply it by the top. And then on the other side, multiply by 7.
Sure.
And then 7 in the numerator.
100%. You got it.
Mhm.
I was just trying to show you an old lady trick. If you don't want to be an old lady, I don't blame you. Okay, so we're working over here. If you do it your way, you do it your way. That's cool. If I do it my way, we'll do it both ways, right? So how would I do it my way?
Sine squared plus cosine squared all over cosine times sine.
It's that easy. This times this is sine squared,
Mhm.
right? And then this times this is
Cosine squared.
And then I have the two bottoms multiplied.
Uh-huh.
And I don't care which order you put it in, just get it up there. Now I get real excited.
Because you see an identity.
Because I see an identity, one that I recognize. And what is it? It turns into 1. Pythagorean identity tells me to. So I have sine over cosine, right? And then 1 over sine cosine. I'll just put them in order.
And then you do the flippy thing.
I do the flippy thing?
Mhm.
I like
Change
the
flip.
flippy thing.
I like
Yeah.
Sine over cosine times sine over sine times cosine over 1.
Reciprocal of the denominator multiply, basically, is what you're saying.
flippy thing.
The flippy thing, that's the
Like,
best.
It's called cube change flip.
Actually, when I do it in my head, like I actually think the flippy thing.
I like
That's how I
that.
always do
The
it.
flippy thing.
A flippy thing every.
Hey, if it works for you, do it.
Mr. Walker keeps
It's the only thing I know how to do.
The cosines reduce, the 1 is ignored,
And we have what we want.
and we have what we
It
want.
works out
Did it
perfect.
this
See,
thing.
the flippy thing always.
I just found it cool that secant times sine equals tangent. That's just.
It's really cool.
Yeah.
Okay, so, are we comfortable? So what you have in front of you, oh, I told you I'd do 2 of you. Let's see. Bum, bum, bum.
Number 1.
Number 1. All right, let's
Yeah.
do it. Well,
And I tried it and I'm like, that's not stuff.
That was,
Okay, help me.
that was me on the exam, to be honest.
that's fine.
In this case, someone helps us. Number one, retest you take. We know, Noah, we know.
We can all bond over.
Oh,
Die.
well, we can all bond over the fact that Noah got a 10 on a test in class. A 10.
Percent.
Yes. He got like 2 out of like or something.
Noah was a special guy, he still did well in the class.
Did he pass?
Yeah.
Did he pass?
Oh wait, that was the test.
No, not the test.
Oh,
Class.
Oh,
What'd you
His
get?
whole tone of voice changed.
See?
Yeah.
Oh, I mean, which part?
Oh, yes. Oh.
Which one's harder?
The test?
No, over here.
Oh,
The
here.
left side.
Oh.
The left side.
The test was definitely harder.
Okay, so the left side is indeed more difficult. So I picked that. What's my next step I typically do?
Change it.
Change it all.
Change it. Oh,
Yeah.
so I'm gonna. So what is secant equivalent to?
One
Um,
over cosine.
1 over
One over
cosine. What is tan?
Sine over cosine.
Okay. And then we have sine over 1. You guys agree? Yes.
How did you know to change the secant? Because if you look at the answer, it has secant in it, so you might think to not change it because in the end you're going to want to have
I
secant.
get what you're saying. I think the old lady trick would be go to sines and cosines because they're easier to recognize and work with. Go
Uh-huh.
back to where you need to be at the end.
Whatever secant, it's still the same as cosine.
Right. 1 over secant is cosine.
Mhm.
So, okay, now what do I have? I have 1 over cosine,
Just get it to cosine with the extra.
and this is what?
Yeah.
Sine squared x.
Sine
Squared.
Over cosine.
And then
The merge, 1 minus sine is a.
And that's an identity?
square
It is.
over
What is it? Cosine over.
that becomes cosine squared over cosine.
Tell me
which
why.
is just cosine.
'Cause it's
1 minus sine
Oh,
squared.
it is cosine.
Pythagorean identity.
Yeah.
It's not the one that's on the bright colored sheet of paper. It's the one I told you you need to know.
Cosine squared over cosine.
Right.
Which is.
Cosine.
1 cancels out on the
1
top.
cancels out.
That's cosine, which is also 1 over sine.
Yeah.
Sweet.
Wow, okay, cool.
Yep. So what do you think? Probably
I'm
right.
pretty sure we had something on.
You might have had
I
this.
recognize this sheet, I believe.
I don't know if it was this exact one, because I don't remember it being this hard.
I just remember the Z-scores. I just remember.
Yeah. I remember the Z-scores, I remember this.
I remember
That's
the
okay.
Number.
It is actually straight up.
Oh, it's actually. Teacher.
So a number of
Yeah.
Yeah, it's kind of unfortunate.
It's really unfortunate.
This
Please.
13?
Yes.
Gotcha.
Mm.
When
That's
I was
actually
walking
really
the Latin,
good.
I would tell them about math class, because I had Latin after that.
Yeah.
Okay.
Right side.
Online thing.
Yeah,
So,
still.
playing it.
Nobody likes cosecants.
Nobody likes
Oh, boy.
Third power,
Okay, so let me talk out loud.
Yeah, I don't
Which
know
one
which
is
to
this?
go with
Both are ugly.
Yeah.
13.
13, sorry. Both are ugly. I think left side is uglier because it's a cubed, and we've never worked with a
Yeah.
cubed. What have we worked with though?
Squared.
Squares.
So just
So that's
take it
where I'm
out.
going to start. I'm going to go, okay, so I've got cosine of x plus 1, and then I'm going to separate it out a little bit. Like so. Because I'm going to go, I've never worked with a cube, but I know for sure I've worked with sine in the first, and I know I've worked with sine squared. Okay? Now, I have to somehow manipulate something to try to reduce things to get to where I need to get, right? So, yes.
Could you do cosine over sine and have that be cotangent? Or no, because the plus one is,
There's
it's
a
like
plus
one term.
Good question. There's a plus one there, I can't separate it out.
Mhm.
But the one thing I do see that could be manipulated, because this is singleton to the first power plus one, yeah. This is the
Sine
only
squared.
thing, right.
Go
Worth a
cosine.
shot.
What is it?
Or
1 minus cosine.
1 minus cosine squared, okay.
Mhm.
Okay, I'm excited, that's exactly right. You see this and you go, okay, I have 1 minus cosine squared, maybe that'll help. So I'm gonna do that. I got cosine of x plus 1 on top. I've got the word sine on the bottom, and I've got 1 minus cosine squared, yeah, right?
Mhm.
You could distribute it.
I'm not gonna distribute the sine through,
Why not? Oh, it's single. I'm sorry.
Yeah.
Yeah.
but I need to recognize something.
That the
Sine over
Plus
sine.
one.
Cosine over sine.
That's the
is-
same thing. Like cosine plus 1 and 1 minus. Oh no, it's
But
squared.
cosine over sine is.
It's squared. No.
Let me do something real quick.
That's all it would be.
Oh.
If I do this,
I see it.
what do you tell me to do?
Oh, difference of 2 squares.
Yeah.
Dang it, I knew
You
that.
see it here, naturally, I hope.
Because 1 is a square. Darn it.
Each of them are squares.
Yeah.
And there's a subtraction in between.
Yeah.
So I'm like, oh, I can
Whenever
even,
there's a singleton, you always have to do that.
yeah, so you can manipulate it a little bit more. So let's look at what happens. You guys know it right off when you saw that. It's just the word, trig words that kind of mess with your brain a little bit. Are we good?
No.
Yeah, oh, shoot, I knew that. Oh, I get you.
So you just pulled it out of your mold.
I did it. What your goal is just try to kind of clean it and clean it and clean it until you go, oh, there we are. You know, because, I mean, naturally when I'm looking at this with the cube, I'm like, where the heck am I going to go with that? I reduced it a bit. Okay, maybe a little bit more. Oh, I can reduce it a little more, you
So
know?
basically the goal is to break it down until you see what happens.
Right, like I do with you guys in math. Break you down until you cry.
Yeah. It's a lot of things.
So then I'm going to reduce
So
that.
then you have
So then I have 1 over.
sine
Sine times
minus
1
1
minus.
minus cosine.
And the thing is, I'm really close, right?
And the 1 over.
Don't hesitate to resort back and look and say, okay, how close am I? Well, I have the 1 minus cosine. Oh, the cosecant on top is just taking that sine and flipping it up,
Yeah.
you know?
Yes, okay, I get it.
Now, remember, I've been doing these a million years, right? It just, I see it now. It comes naturally to me.
I'm confused on how you got that.
How do I what?
How did you flip
Well,
this
you
up?
know how you
Inverse.
inverse something when you flip it? Like if it's negative, you turn it to positive when it flips over?
What are you doing that to? The
It's
sign?
the sign. The
So,
sign.
look at it like this.
1 over
1
sine.
over sine times 1 over 1 minus cosine. You see that now?
You just split up the fraction.
I split up the
I
fraction.
think we've done that before.
Yeah, I just did it in my head, unfortunately. And I recognize that this becomes cosecant.
Then you flip it up.
And then I flipped it up.
Okay.
I am so.
1
you-
minus 1 over sine
Uh-huh.
is cosecant. Cosecant over 1 times 1 over minus 1 minus cosine is cosecant over 1 minus cosine.
Oh, okay.
Yeah.
Alright.
All right, so are we on the same page? We've done 3 together, right?
Yep.
I would like you to start working on them, please.
Dumbbells about